going to talk about deadlock and DBMS. Okay, so first question, like, what is deadlock? So yes, so if you see here deadlock, so there are various definitions around deadlock, but what you can say if somebody asks you a question. So deadlock is the undesired situation in which two or more transactions have to wait indefinite amount for each other resources which are being acquired by them. And yes, but none of the transactions is willing to give up the allocated resources to the other transactions so that they can complete. So this is one definition, but in a simple word I would say, so there are T1 transactions and T2 transaction. Okay, they are running, and T1 is trying to acquire a resource which is acquired by T2, and a similar manner like T2 is needed as resource which is acquired by T1. So this is the kind of a situation where deadlock occurs. Okay, so this is the best and simple definition. To understand a broader way, we have an example of traffic light. Okay, so yes, we often see traffic jam in our city. Okay, so this is the best example of deadlock. Whenever there is a traffic jam, okay, you can see the vehicles got stuck on the road itself due to many reasons. Okay, so this is the best examples I would say to understand what is a deadlock actually. Okay, so in this case, like the vehicles are the transactions and the road, okay, the path is the kind of resources and which are required by these vehicles. So such type of cyclic deadlock we often seen in our city. So yes, this is kind of one example I would say. Second example in terms of technical, so there are two transactions, T1 and T2. Yes, the T1 running on a student and T2 running on a grade. Okay, but now T1 wants to update the grade of the student which is in the grade table. Okay, at the same time T2 is the transactions which require to fetch the data from the student table. So now this is the cyclic situation where the deadlock acquire. Okay, deadlock occurs, not acquire, it's occur. Okay, so these are two example for the deadlock. Next we have deadlock condition. Okay, so what are deadlock conditions? Okay, so now Coffman is a person who has given the 4 condition. One is mutual exclusion, hold and wait condition, no preemption condition. Okay, then we have the circular wait condition. So we'll see one by one. Okay, so what is mutual exclusion? So one or more resource utilize. So what happened in generally? So there should be something like the one resource will be acquired by one transaction only. So if it is not happening, I mean the one resource acquiring the lock for the other and waiting for the other resource which is held by the again another resource, another transaction, then yes, deadlock will arrive. If such type of situations occur, yes, deadlock will be there. So this is mutual exclusion. Second is hold and wait condition. So usually what happens, the transaction hold the resource and request for some other resources which is again held by the some other transaction. Then the chances are more that there will be deadlock. Yes, we have seen the deadlock's definition. Third is no preemption condition. So what is the word preemption is suggested? So in computer language, preemption is a terminology. So it is going to halt the executing process, okay, or it is going to interrupt the process which is in executing state or running state. Okay, it's called a preemption. So no preemption condition. Okay, so access to the resources can never be taken forcefully from the running transaction. Okay, so let's say there are the transactions which is currently running fine, but now the resource required by some other transactions and we are forcefully taking the resources which is acquired by that particular transaction. So if such things are happening, yes, there will be deadlock. Okay, next is circular condition. Okay, circular wait conditions. Yes, now to understand this is the best example I have given. This is the one particular diagram. Just let me show you. See, now there are 3 transactions, P1, PJ and PK. Okay, all are now in cyclic condition. So these particular transactions require the resource which is held by the PJ. Similarly, PK is also running, which required the resource which is running by the PI, and again PJ required the resource which is acquired by PK. So yes, this is one kind of cyclic condition where deadlock will arrive. Okay. Yes. Now we have seen what is deadlock. We have seen the conditions. Now how to handle deadlock? Yes. Here, so there is ostrich algorithm. Okay, no, to handle the deadlock. Okay. So what is first? What is ostrich algorithm? And yes, how to detect, avoid the deadlock, and how to prevent it. Okay. So yes, ostrich. What is ostrich algorithm? It seems like this is the approach is derives its name from the behavior of an ostrich, which is to stick one's head in the sand and pretend there is no problem. Okay. So this is what the as ostrich algorithm says. And why ignore the deadlock? Okay. Why to ignore the deadlock? Because deadlock is very rare case, and cost of handling is very high. A reason, whenever there is a particular process got hung, okay, so ultimate you need to reboot your system, okay, which is an unexpected downtime in the business hour itself, which resulting into a huge loss of revenue. Okay. So this is how we can avoid why to ignore the deadlock. Okay. Now we'll see how to detect and avoid. Okay. So there is method called as wait for graph. So what is this method? We'll see. Okay. If I go here, wait for graph. Yes. So in this method, detect deadlock involves creating graph-based transactions and its acquire a lock. Okay. And the transactions are from accessing resource simultaneously. If the created graph contains cyclic loop, it means the deadlock exists. So wait for a graph is again like the example I'll give you. This similar manner we have seen here. This cyclic situation. Okay. So yes, for the wait for a graph, the deadlock is cyclic wait condition. Okay, where the three running transactions are executing in a similar manner, and the resource required by them are acquired by each other. So yes, so this is how the wait for a graph. Yes, so this happens usually in small databases. Okay, in size of a small database. What happens when there is a large number of database? So yes, so that particular event you need to avoid the deadlock. Okay, we'll see. Okay, so now how to prevent the deadlock? So wet die scheme, okay, scheme, and the wet wound wet scheme, we'll see. Okay, if you see here, we'll see the first one. So when the transaction needed resources that are already locked by some other transactions, the DBMS check the both the transactions timestamp. Okay, so it will ask older transaction to wait until the resources as being available by the other transaction. Okay, so this is wet die scheme. Okay, another is like wound wet scheme, like it is exactly reverse of it. When the older transactions demands the resources that is already locked by the younger transaction. Okay, so younger transaction is forcibly killed. Okay, and it will release the resources, then it will the resource will be given to the older transaction, and yes, after some interval of time the younger transaction will be restarted again. Okay, yes, this is how the wound wait scheme I would say. So this is how the deadlock in DBMS. And yes, in the next session we gonna talk about types of RDBMS, sorry, types of DBMS. Okay, types of databases. Okay, cool. Thank you.